Hi. In this lecture we will try and understand the basics with regards to a 7-segment display. So as part of this lecture I will first speak about what a 7-segment display is, what are the individual 7 segments, then we will discuss the concept of a common anode and common cathode. Then I would like to spend some time discussing about the practical aspects of a 7-segment display, how actually we will be using a 7-segment display, the pin connections connecting a 7-segment display, and then I will discuss the concept of how we can generate different patterns using a 7-segment display. So let's begin. Well, a 7-segment display is also more commonly known as a 7-segment LED display. LED, which we've seen in a previous lecture, stands for light emitting diode. And a 7-segment display is basically nothing but a few single LEDs put together, which are total 7, and together they form something called as a 7-segment display. If you see that an LED has an anode and a cathode, so we have a total of 7 anodes and 7 cathodes. Now typically you would use a 7-segment display to display numbers or to display characters such as A, B, C, so on. Since we are also using this to display numbers, a practical 7-segment LED display has something called as a DP or a decimal point, which is also an LED. So although it is called a 7-segment display, but in actuality we have 8 LEDs. Please make a note, we have 8 LEDs. Well, that said, if I want to show the letter A, then I would do that by glowing the following LEDs, which would be this LED, which in forms the letter A. Now, a 7-segment LED is divided into 7 segments, which is A, B, C, D, E, F, G. The reason behind doing that is it is easy to understand and it is more organized. So we will see as a future part of the same lecture that when I use a 7-segment LED, it is easier for me to identify that this LED is LED A, this LED is LED B, and so on. Please make a note here that these characters A, B, C, D, E, F, G have nothing to do with these display characters that you want to display. They are two independent phenomenons. Okay, that said, let's quickly understand another point, that we have 8 LEDs, which gives us a total of 8 anodes and 8 cathodes. That makes it a total of 16 inputs. Now, as we see, that is a very high number. So how do we tackle that? Since we have 8 anodes and 8 cathodes, just to interface one 7-segment display, I would need 16 wires which need to come to this. That is not practical. So how do we do that? Let me explain this by first taking a simple example of just 4 LEDs. Now, if I have 4 LEDs, that would give me 4 anodes and 4 cathodes. So, if I have 4 LEDs, such that I name them as LED 1, LED 2, LED 3 and LED 4. We know that this is the anode and this is the cathode. Now, if I want to glow LED 4, then I would connect the anode to VDD, that is a higher potential, that is 5 volts or 3.3, and connect the cathode to a low potential, that is 0 or ground. Similarly, if I want to glow LED 3, I would do the same, LED 2 and LED 1. Now, I have 4 anodes and 4 cathodes. That makes it a total of 8 wires. Yes, we do understand this point. Now, what if I can connect all the 4 cathodes to one common terminal? If I can connect all the 4 cathodes to one common terminal, which is ground, and leave the other 4 anodes open. I leave all the 4 anodes open. Will my LEDs glow? So if I connect this to ground, that is 0 volts, that is all these cathodes, that is cathode 1, cathode 2, cathode 3 and cathode 4, would any of my LEDs glow? The answer is no, unless they would only glow if I connect this to VDD. Then there is a path that exists for LED 1. We know that my LED 1 would be forward biased, and hence LED 1 would glow. Does that mean my other 3 LEDs will glow? The answer is no. So, what did I just achieve? I can control which LED glows. Well, I had that in the previous case as well, which was 8 anodes and 8 cathodes. But more importantly, now I have 4 anodes and one common cathode terminal, which is equal to 5 terminals, and hence I just saved 3 terminals. Please understand this, that from 8 now I went down to 3. Well, this concept is fine. This particular configuration is called the common cathode configuration because all my cathodes are connected together to one single terminal, that is ground. That said, let us understand what would happen if I would have something called as a common anode. In a common anode configuration, I would connect all my anodes, I would short them together and connect them to VDD and keep my cathodes open such that only when I give a 0 here at this terminal would this LED glow. So it's directly the opposite of a common cathode configuration, just that now the anode is shorted, and for any of the LEDs to glow, I have to make sure that the common anode is connected to VDD and the respective cathodes should be given 0 or ground. But again, this is with respect to 4 LEDs. Now please let's understand this with respect to our 7-segment display. So as we know that in the 7-segment display I have 8 LEDs because I have one for my display point as well. And as you see that all the 8 cathodes have been shorted into one terminal and the anodes have been left open. On the other hand, in a common anode configuration, you see that all the 8 anodes have been shorted, leaving the cathodes open. So effectively, now I have a total of 8 plus 1, that is 9 terminals instead of 8 plus 8, which would have been 16 terminals. So now I effectively save 7 pins on my system and I get the same functionality. Please understand that. Very important point. I get the same functionality. Okay. That said, let me just quickly repeat this, that if, for example, I would want my display point LED to glow in a common cathode configuration, then this would be connected to ground, and if I would want my display point LED to glow, I would give a 1 here or a VDD, and hence there would be a path through and only this LED would glow. Similarly, I can control which LED I would like to glow depending on where I would give 1s and 0s. This is again for a common cathode configuration. For a common anode configuration, I would give VDD at the common terminal and accordingly give 0 at the respective terminal to control that particular LED. I hope this common anode and common cathode configuration is clear. It is very important because when you go to buy a commercial 7-segment display, you need to ask, is this common cathode or is this common anode? Okay? Alright. That said, let's understand how would we practically use a 7-segment display. Now, if you go to the market, you will actually see a 7-segment display that looks like this. It has a total of 10 pins. Yes, I know that I previously said 9 pins, but for symmetry purposes, since there are 5 pins on one side, they decided that they would repeat 2 terminals, which we will just see. Now, if you hold the 7-segment display such that your display point is towards the bottom right, if your display point is to the bottom right of your hand, then this particular pin is your pin number 1, the second pin is pin number 2, pin number 3, pin number 4, pin number 5, 6 would be here, 7, 8, 9 and 10. Now, if you look at this figure, that is exactly what I'm trying to say. So, pin number, the first point that would come to my mind is I should have A at pin number 1. Well, it doesn't make sense that way because if you see that A is located here, the A LED, hence I would want that my pin of my segment A, which is this, should be closest. Hence pin number 7 is A, pin number 6 is B, which is this one, and so on and so forth. So to take it in order, 1 is E, 2 is D, 3 is ground. Now I will come back to this ground pin in a short moment. 4 is C, 5 is your display point, obviously because the display point is closest here, and then I have B, A, again I have ground, I have F, and then I have G. Again, this is A, B, C, D, E, F, and then G. So now I said that I would come back to this ground point. Why is this ground? Can you think why have I specifically said that this is ground? The reason behind that is this particular 7-segment display is manufactured in the common cathode configuration. So since this is a common cathode configuration, hence I need to make sure that all my cathodes are connected to one terminal, which will then go to the ground potential. For symmetry, we have two terminals, that is the pin number 8 and pin number 3, which have both been provided so that they can be connected to ground. So I hope that this aspect was clear of how a practical 7-segment display would be used. And if you want a schematic diagram, then let's understand it here, that if I have a common cathode configuration, then you see that all the cathodes have actually been shorted and then given to ground. Similarly, you have two ground terminals. You can choose either to connect this or both actually, but just one of them would suffice. Similarly, for a common anode, you see that all the anodes have been shorted as just like this. But please understand that your anode terminals have to be connected to VCC or VDD, which would be logic high. This would be logic 0. I hope that this is clear. Again, just for a quick revision, this is pin number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Similarly, this is 10, this is 1, this is 6 and this is 5. I hope this was clear. Now, just to conclude this lecture, I would quickly want to revise with you how we would generate different patterns. Again, what kind of configuration is this? This is a common cathode configuration. So pin numbers 3 and 8, what would I connect them to? I would connect them to ground. Now, suppose I would like to display the number 1. So how would I do that? I would decide that I would like to glow LED B and LED C. All the other LEDs, which is A through G, A, F, G, E and D, would actually be off. So A should be off. A should be at 0, because then this LED is reverse biased and will not glow. B should be at 1. C should be 1. D should be 0. E 0, F 0, G 0. Now if I choose to glow my display point, then it will be 1. If I choose not to glow my display point, then it will be 0. Well, that was the number 1. Suppose if I would like to display the number 2, how would I do that? I would need A, B, G, E and D. That's it. What would I do here? I need A to glow. So hence now A would be 1, B would be 1, C would be 0, D would be 1, E would be 1, F is off, hence F would be 0, G has to be on, hence G would be 1. I choose not to glow my display point, so hence display point would be 0. So that would glow my number 2. So now that said, it is quite clear as to how I would display different patterns, numbers or characters on my 7-segment display. So I hope that this lecture on the fundamentals of a 7-segment display it's quite clear. In the next lecture, we would see how to implement the 7-segment display with the platform that you're working on, and we will see a practical lab on how to interface a 7-segment display. Thank you.